Hello engineers, welcome back. In the previous video, we got some theoretical understanding about hashing, hash table, and hash functions. In this video, we're going to use that knowledge to solve a Leet code question. Okay, I hope you're ready. Let's get started. So in this video, we're going to solve this question, number of good pairs. So let's try to understand the question and then we'll see a solution. So given an array of integers, return the number of good pairs. A pair ij is called good if nums of I equal to nums of j and I is less than j. Okay, this is very similar to the frequency counter question. In the frequency counter, we were looking at the number of occurrences of any element. Here we are looking for the number of occurrences of a good pair. Okay, and there is some condition for a pair to be good, and we simply need to return the number of good pairs. Okay. So let's try to understand this with an example. So if this is the array 1, 2, 3, 1, 1, 3, there are 4 good pairs in this. And these pairs that we are seeing here are nothing but indices. So for example, if I talk about the first pair, it is 0, 3. So 0th index has the number 1. Third index also has the number 1. So this and this becomes a pair. Similarly, 0, 4. So 0, 4. So this is again a pair. 3, 4. 3, 4. This is again a pair. And 2, 5 are both 3s. So this is again a pair. Okay. So how do we approach this? So let's take this to our whiteboard. So the approach is quite similar to our frequency counter. What we need to do, we need to keep track of the number of good pairs, right? So we need a tracker for good pairs. So let's call it pairs. Initially, let's assume that there are 0 pairs. And as we iterate over the array, once we find a pair, we will increment this number, right? So how do we find a pair? So as we go through this array, we can build a hash table, and hash table will be the frequency counter table. So it will look something like this. So if this is my hash table, this will be of size 4 because the maximum element is 3. So let's have 4 elements here, 0, 1, 2, 3. And this will be a frequency counter. So as we iterate through the array, we fill this hash table. So how do we fill it? We look at the first element, and whatever is the element will be the index of the hash table. So we increment it by 1. So initially they will all be zeros. So as we find the element, we increment it by 1. And we move forward. The next element is 2. We increment this by 1. And the next element is 3. We increment this by 1. And then the next element is 1. We increment this by 2. And then another 1 is there. We increment this by 3. And then 3 is the last element. We increment this by 2. So this is how my final hash table will look like. Now, how do we find pairs? What is the definition of a pair? Definition of a pair is both numbers should be equal, right? So as I am iterating through the array, I found one occurrence of this. If I find the second occurrence, that means I found a pair, right? If one is occurring 2 times, which means I found a pair. If one is occurring 3 times, first let's talk about 2 times. If a number is occurring 2 times, then we have found a pair, so we need to increment it, right? So if hash table of whatever number is 2, then we simply do pairs plus plus. So we found a pair. Now the condition is, what if the frequency is greater than 2? What should we do then? So if we can understand this logic, then we have solved our question. So we know that if we find a couple of occurrences of any element, we found one pair. But as soon as we found the third occurrence, what happens? Let's see. So if there are 2 1s and this is a pair. So pairs is 1. But as soon as I introduce a third one, how many pairs does this have? This is a pair, this is a pair, and this is a pair. So there are 3 pairs in total. And if there are 4 ones, what will happen now? So for 3 ones, we already had 3 pairs. If I introduce a new one, it will introduce 4 more pairs. So it will pair with this, it will pair with this, it will pair with this. Sorry, 3 more ones, 3 more pairs. So this will become 6 pairs in total. If I introduce the 5th one, it will already have 6 pairs because we already have counted 6 pairs, and this 5th one will introduce 4 new pairs. So it will pair with this guy, with this guy, with this guy, and with this guy, right? 4 more pairs. So total will become 10. So if you can observe a pattern here, for every new addition, we are incrementing the pairs, right? By how much margin? So for every addition, if I'm introducing the 5th element, whatever was the previous count, if there are 4 ones, we are adding 4 here, 6 plus 4. When I was here, I had 3 ones. When I had the 4th element, I was adding 3 to the previous count, 3 plus 3, right? So there is some pattern here. So what is that pattern? So the pattern is very simple. If there is more than 2, we have found additional pairs. So we simply say pairs plus equal to whatever was the previous pair count. So when we found 2 ones, we found the first pair, but now we found the third one. Third one should introduce 2 more pairs, right? So how do we get 2 more pairs? So here it was like this, right? 1 plus 2 will give us 3. We simply say whatever is the frequency right now, hash of I. Now hash of I will become 3, right? Previously there were 2. Now we found the third one. So hash of I will become 3. So if I add 3 to this, it will become 4. But I don't want 4. I want only 3 because I already added the first pair here. So I don't need to add it again. So I will simply do -1. And that's it. That is the whole logic. Okay. So if you can understand this intuition, the logic is quite simple. So first we have built a hash table, and then we are building the logic for calculating the pairs. So just to explain one more time, we had 2 ones and the number of pairs, which was initially 0, went to 1. This is here, right? Once we find the number 2, the frequency 2, we have incremented the pairs to 1. But when I have the third one, which means hash of I has now the value 3. When we have 3, how many pairs do we need? How many pairs does this have? It will have 1 pair here, 1 pair here, and 1 pair here. Total, it will have 3 pairs. Out of these 3 pairs, I already added the first pair to my pairs count. I need to add 2 more. So how do I get 2 more? I simply do 3 minus 1, right? That's what I did here. Hash of I is 3. 3 minus 1 will give me 2. So I will add 2 to the previous count. Previous count was 1. So I will do plus 2 and this will become 3. Now if I had a fourth one, this will introduce 3 more pairs, right? How do I add 3 to this? I simply do 4 minus 1. So 3 plus 4, 7 minus 1 is 6. So I will get 6 here. And that's it. Okay, so that is the entire code. So let's try to code this in Leet code. So let's first build our hash table. We already know how to build it. We use a new vector of int, let's call it hash. Now we need another number to return. This will be pairs. Initially pairs will be 0. Okay, now there is one thing to note here. What will be the size of this hash table, right? We know from this example that the size of this hash table was 4 because the maximum elements was 3. But here we don't know. This nums array can have any number, right? So how do we build a hash vector generically so that it will accommodate all inputs of num? So for this, we will look at the constraints. So here it says nums of I lies between 1 and 100. So nums will never go beyond 100. Okay. So I can directly use this logic. So I can say hash of 101, because the maximum element can be 100. I will need the 100th index in my vector. So I will use hash with the size of 101. I can do it the other way. I can calculate the maximum number in the vector by using a new loop and use that as an input to this hash initialization. Both of them will work. But since I already know the constraint, I'm just using a generic logic. Okay. Now let's build our hash table. So we will iterate through our main array, main vector. So as we build the hash table, we can also keep track of pairs. First, let's build the hash table. Hash table is simple, hash of nums of I plus plus, that's it. So nums of I is, let's say I is 0, nums of 0. Nums of 0 is the number 1. Hash of 1 will become plus plus. Oh, for this I also need to initialize the hash vector with zeros, right? So I can do like this. So now everything is initialized to 0. So I am saying give me a hash vector of size 101 which are initialized to 0. Now when I do plus plus, the hash of 1 will become 1 instead of 0, right? So that is done. Now let's talk about pairs. So pairs logic we already know from this dry run. If hash of I equal to 2, pairs plus plus. If hash of nums of I equal to 2. So when I find the second occurrence of any number, I need to do pairs plus plus. But when I find the third occurrence or more, hash of nums of I is greater than 2, then I need to add to the existing pairs, pairs plus equal to whatever is in the hash nums of I minus 1. So if hash of nums of I is 3, I get 3 minus 1, 2. So I will add 2 to the already existing pair. So I will get 3 here. And that's it. So we simply return the number of pairs. So I hope we have done everything right. Let's run and see. Yep, let's submit. And it is working fine. So as you can see, we have used the concept of hash table to solve a lead code question. So if we didn't use a hash table, we would have to, count the pairs in a different way. We would have to keep track of every count, and using nested loops, we would have to keep track of the remaining occurrences. So that would be a little costly in terms of time. And hash table helps us in creating the frequency counter, and this operation is of time complexity O of n. Okay, so that's how we can use the hash table. So if you have any questions, you can definitely ask me, guys. Thank you so much for watching. Please don't forget to leave a like and comment if you have any questions, and don't forget to subscribe to the channel and bookmark the playlist so that you don't miss out on a future video. I will see you in the next one. Thank you. Cheers.